Okay, so the objective of today is we're in our series of effectively going through one of the past papers, and we're going slowly through it, working through various aspects of the past paper. We went through quite a lot of the, I think, fundamental concepts of what was required in computer science for the first semester, and we're very close to finishing the actual paper itself. We will probably not finish it this evening, but maybe tomorrow. But before we start with or continuing with the actual paper, I just want to make everybody aware of just one administrative aspect. We have all the application for the remote assessments have now closed. So we will send a final personalized email to everybody that's on the Computer Science 1A class list. And in that email, we will again just confirm the exact venue that you will be writing in, as well as the exact session. Remember, there can be either a morning session or an afternoon session or a remote session. So any one of those three sessions, you will see in your email the exact session. Also, the email will just mention to you, please bring a print out of that email that you will receive tomorrow. If you can't print it out, then you must just display it on your phone on the day of the semester test when you walk into the venue. The only reason why we want to do that is to ensure that we don't have students not allocated to a venue going into the wrong venues and then creating unnecessary amount of people in the venue. So please remember, we have to keep our social distancing. We have to make sure that we don't crowd venues too much. That's why there's a limit to the total number of students per venue, and that's why you have to stick to the venue that has been allocated to you. So please also remember then to get to the venues at least half an hour before the time, so that you know exactly where your venue is. We have sent the email out that explains where you can keep your things for in the safety places, so that you don't bring in bags, you don't bring in computers and things like that into the venue itself. Okay, let me just quickly see if there's any questions. When it is said that to use OpenBook, does it allow us to use notes from our books or just Eve? I think that has been discussed on Discord, but effectively you can use the notes that's on Eve. Then when will remote applications be finalized? We did get the latest, it closed at 3 o'clock, and we will send out an email tomorrow, but effectively that you should not have a problem in writing your remote test. Are phones allowed? Phones are allowed, but it must be switched off. So if you use your phone to show the email, just make sure that you switch it off as you walk in. The invigilator at the door will also mention this to you. How will we show you with our phones? Very simple. You show it and then you switch it off as you walk in. Can we print out the Eve notes? Let me just confirm, guys, we have discussed this on the Discord. I just don't want to say something that we have not said. So please look at the Discord. We have discussed the whole OpenBook situation there. And if you're still not sure, ask on Discord. Again, everything to do with OpenBook, ask on Discord. I'm not going to handle it right now. Okay, please ask on Discord so that we can get one message going out regarding the whole OpenBook. But effectively, the notes on Eve is perfectly okay, but getting access to code and things like that will not be okay, because we don't want you guys to copy and paste the code. That's the main thing. Okay, so for now, let's park that. Let's move on to our actual lecture. Let's just wait for it. Now, what's interesting is this is my lecture itself, the solution for the past prac that we were busy with, and this is the actual past prac with the whole epidemic modeling and so forth. And last week we finished our movement function, and while I was going through the actual preparation for this evening's lecture, I actually saw that for some reason the characters started to disappear as they moved. and I didn't quite understand why. So I did a few things in the submission, which I just want to quickly show you. I firstly outputted a count of the total number of infected people, or the total number of infected characters, the total number of recovered, susceptible, and immune, so that I can confirm that my hypothesis and what I was seeing was in fact correct. So I created a small little function called count feature. Now let me just share with you what count feature does. If we look at the prototype, it takes in the two-dimensional array, the total number of rows, the total number of columns, and potentially the feature that I want to count. So how many susceptible people, how many immune people, how many recovered people, and how many infected people or characters. Then during the implementation, this is effectively what happens. It's a very simple little function. It returns, obviously, an integer, which is the count. And I initialize a variable called int count in the first line of code. And at the last line of code, I actually return that. And then I iterate through each of the cells in the world. And I say, if that cell is equal to that specific feature that I'm looking for, just increment the count. Okay, so that's what I'm doing here. I'm basically counting all those features. Once I did that, I actually saw that the count went down as time went down. So I realized that there's a problem in my, not output world, sorry, in the move character functions. Now let me just show you what happened here. So the normal move characters function was all good, meaning there was no problem in the temporary array and copying the array, etc. But there was something not perfectly correct with the move character. Let me just show you what the problem was and how I then fixed that. So when we looked at the move character, okay, so this code, this whole boolean not empty, and this do loop was not in here. So this is the original code that was in. We had this int row, in direction, blah, blah, blah. All of this was all good. And then I had the following if statement to check if a character was in the world. Then we did a few things. And I first checked if the destination location was empty. Then I put the character from the main world, which is this guy here, into my temporary location. This line of code was not here. And then I said, if it wasn't there, then immediately just keep the character in the same location. So basically put the character in the same location, meaning from the place where the character was in the world to the place in the temporary array. Okay, and then I did the same when, if the character was not in the world, I tried to keep the character in the same location. Now the problem with this line of code, or these two statements, was that potentially what might have happened was another character could have moved into the same location where we want to keep our character. Okay, so let me see if I can explain this in Excel. So let's say, for instance, we had two characters. Let's say we had a susceptible character there and another susceptible character there. When we started in that location right here, this, let's call it S1. That guy is S2. And that S1 character got a random location and it moved into this location right there. Okay, can you see they are in exactly the same location? If we 0, 1, 2, 3, 4, 0, 1, 2, 3, and 4. Okay, that's it. And then 0, 0, 1, 2, 3. So S1 basically is in the same location in the next iteration of that S2 is. Now let's say, for instance, S2, we randomly chooses a location and we move him outside the world. Now, in the previous logic, what would have happened is we would have said, okay, S2, you stay where you are, and as soon as I do that, boom, it overwrites the location that S1 was in. Now, that is a problem. You can't just override. I can't keep S2 in the same location. So basically, all I did was I changed the logic to say that if the destination, if there's another character already in the temp array, then I'm going to keep on looping. I'm going to keep on trying to place S2 in the destination in this temporary array until I find an empty space. And that's what I did. So I jippoed the code a little bit. And the way that I did it is I created this flag called Boolean not empty. So I assume that the destination is not empty, and I set that to true. And I changed all of this logic, and I put that in a do while loop. So I said do while the destination location is not empty. And I assumed I will only change this flag if I have specifically tested that the destination is empty. So basically, the normal situation, if the character has to move, and originally if the destination is empty, then I actually move the character and I switch off that little flag. But then, just instead of just doing a normal else, I also again just test. Listen, is the temporary location where I'm actually at the moment, is that also empty? If it's not, then I don't do anything, which forces the loop to try again, get a random location, get a destination row column, and then try and move it again until eventually it finds that that temp location is also empty, and then I can place the character. The same here, if it's potentially outside the world, I will keep on trying until I find my current location to be empty, or I get a destination location to be in, a place where I can put the player. Okay, this is also sometimes a bit of a problematic code, because effectively what can happen is this loop, we may get into a situation where this loop basically never finishes, and it can actually create our program to hang. So it's not perfect, but it is at least okay. At least things don't just keep on disappearing inside the game world. Okay, so again, I'll upload this code when we're done with the lecture this evening. Okay, so this is what the issue was in the existing code. Let's just see if there's any questions. I'm not sure if this has been asked, but would it not be possible for one to request to be moved from the afternoons? I think those requests have already been answered, Mr. Ishmael. If you don't send us a request email before tomorrow morning, then you will be in the same situation. There are a few students that we had to move because of clashes to tests. They've already informed us. Okay, good question. Why do we put those specific move directions in the parameter of getRand? Okay, let's have a look. This was discussed last week so that we can get a random location or a random direction. So please look at last week's lecture. This was actually discussed during last week's lecture. But effectively, all it does is it generates a random number between 1 and I think it was 8, and that is the location, or that is the direction that we're going to move into. Okay, so now we're at this section of our code. So we're now in this update portion. Now let's take each of this very slowly, because this can get a little bit more complicated. So the first bullet says that a susceptible or a recovered character has a cumulative chance of becoming infected for each infected character within a 1 square radius of each other. So let's have a look at the base chance is obviously specified in the command line. So what does this mean? So it's either susceptible or recovered characters. So let's go back here. Let's just get that out of the way. So let's assume that I've got a recovered character there. And then I have an infected character there and another one there. What that basically means is that there is a chance, and I think in our example, let me just see, what was it? We said that infection, total infected. Okay, there's a chance to get infected, which was our third command line, which means it's this 40. Oh wow, that's quite high. 1, 2, 3. Yeah, that is too high. I'm going to have to change that 40 to a little bit of a lower number. But so there's a 40% chance, we said, for someone to get infected. That is very, very high. Okay, because it's cumulative. So what does it mean? So I'm just going to make a note of that 40. So I'm just going to say 40 there. But cumulative basically means have a look at this character. let's count the number of infected characters around it. And the easiest way to do it is to create a little loop. So the loop will start at, so my current row and column that I'm evaluating is at row 1 and at column 1. So basically my loop has to start at R, where R is equal to row minus 1. So row minus 1, and it has to go to row plus 1. And the column counter will have to go from column minus 1 to column plus 1. That's the current row and column. The row starts at row minus 1, meaning it's at row 0, column minus 1, column 1, so it starts at 0. So I basically have a little for loop that will evaluate these cells around the character. And I will count the total number of infected characters around that character. So typically, I need some kind of function called count around that will count the total number of infected characters around it. And all I do is I count. So let's say there's 2 characters around it. So there's 2. I take that 2 and I multiply it, because it's cumulative. It's 2 times 40, and that is the chance that this character will get infected. So that obviously will give us a sum of 80. So there's an 80% chance that this recovered character will now get infected. So, I mean, that's a very, very good chance to do that. All right, so that's the logic that I'm going to try and implement. So I'm going to create this little counter. Well, firstly, I'm going to create an update function. And the update function will again create a temporary array that would update where we will work in. So that basically means that as we go through each of these cells, we will not make a change in the current status of the world. We will always create an updated status in the new environment. So for instance, if an infected character stays infected, it stays there in the same place. If the recovered character has to now get infected again, it changes to an I, and so forth. You cannot go and make a change in the current status. Remember, as we loop through this, these I's can potentially change. Okay, let's just stop quickly. For those that's viewing this video at a later stage, your late viewing code is ZE92 %4. ZE92 %4. Okay, that's for the late viewing register. If you're not viewing this live, ZE92 %4. All right, so that's again why we need this temporary. Because if I went ahead and I changed, let's say first I look at it and I say, okay, so this is an infected character. This guy is now potentially recovered. Because it's only supposed to affect the next round, this recovered character, when I eventually get to it, will not take this guy into consideration. So the correct answer is to always keep your existing state stable and make any changes in, let's call it the next version of the world. This same principle we used in the prac when we looked at that automata, where we actually grew the automata in I think it was prac 6 or something like that, and we used the same in prac 7 as well, and in prac 8, and we will actually use this principle in prac 9. So that's why we have to use this temporary array to put the changes in. Once we've finished and we've covered all the cells in our main loop, we will then copy this temporary array into the normal array, and this will now be our new state for the next round. So that's important that we actually do that. So we typically look at that kind of principle, whether you've applied it. If you have not applied it, then you will lose some marks in the algorithm implementation section, because these things like the movement and the update, they are affected by the algorithm implementation of our mock. So again, it's not going to cost you. You will still be able to pass this semester test or exam, but you will not be able to get full marks for it, obviously, if you don't use this principle of a temporary array. So let's go ahead and code this in to our solution. So we're first going to get an update status function here. Now, we haven't really done anything with the ch input. We'll still do that a little bit later, but for now, let's go and update our game world. So this update is not going to return anything, and it will take in my type2 array world, and I need the total number of rows, and I need the total number of columns, and I need these chances. I need to know what these chances are. So the chances of getting infected, the chance of being recovered, and the chance of getting immune. Okay, I need those things. So I'm going to have to pass these things in as parameters. So let's put them in as parameters. So that's the one. Chance of getting, chance of getting infected, the chance of getting recovered, and then the chance of becoming immune. Okay, I think that is it. Putting my semicolon there, and I'm creating the implementation right here. Okay, so before I continue, let's just make sure I did not make a syntax error anywhere. Okay, that looks good. Next, I just want to call the function as well. So go back to my main. Right. In total rows, the total columns, and the array world. There we go. So there I'm actually going to call the function, and I'm going to implement it right here. Okay, so let's get the full, remember, so let's create this temporary array that we're going to need. Where am I? There we go. So it's the same what we did here. So I'm just going to copy and paste this. Guys, get used to, in fact, I'm going to take this whole thing as is. I'm just going to make some changes to it. Obviously, the code in here will look totally different, so I'm going to get rid of that. But this basically creates a little temporary array. At the end of the day, it will copy the temporary array back to my array world, and I will deallocate it. Okay, now, as I go through each of the cells, I have to handle each of these cases. Now, the first case that I want to handle is the, let's call it the infected case, infection case. Then I will handle a recovering case. And then I think okay, they have a fiction, and then we have to worry about an immune case. The character recovers. Okay, but that is when they immediately become immune. So we'll handle that in the same recovery case. If a character recovers but that does not become immune, they become recovered. Okay, that's fine. So we'll keep it like that. So it's only those two cases for updating that we have to care about, and our focus is on this infection case. So let's first see. You can, if you want to go and create two different functions or different functions for each of these cases. I'm going to, for now, just put it in my actual code. So let's do this. If array world, then I have to look at the row and the column, is equal to val infected, no, recovered. Oh, it's susceptible or recovered. Or array world is equal to value immune will never be susceptible, recovered. There we go. So if it's either one of those characters, then we're going to have to see whether we want to, whether they are going to get infected or not. Okay, so just want to think about the temporary array here. Let's worry about that now. Okay, so let's get the count around function correct quickly. And this thing will return an integer. It's going to take count around, and it will take in effectively these parameters, the total rows and the total columns. And I need the current row and the current column, and I want to count a specific feature as well. Perfect. So let's go ahead and get a little bit of a counter here. Say 0. Let's return that. And then I'm going to create a little for loop for int r equals int row minus 1, while r is less than or equal to int row plus 1, r plus plus. And then do the same for my columns. Int column minus 1 until column is less than or equal to int column plus 1, column plus plus. Then if array world is int feature, then int count plus plus. This should count around. Okay, so far so good. All right, there's a few errors. Error expected primary expression before this token. Oh, there we go. Column. Okay, that looks good. Stop that. So if it is that, okay, we're still busy with count around. Right, so this returns the total number of items in that environment. So let's see, int, let's call it infected. Equals count around, array world, comma, int rows, int columns, row, column, val infected. So that does that. And then, so the int infected is equal to int infected spelling like times count for an infection. Remember, if we count the two that's infected, then 2 times whatever the chance is. Now I need a random number. So int chance is, I think it's 8 rand. 8 rand between 1 and 100. Okay, so this will generate a random chance for me. And if int chance is less than or equal to whatever the infected chance is, then this character now becomes an infected character. So that happened in my temp array, or array temp. is equal to val underscore infected. If it doesn't do that, the destination location stays normal, meaning the character stays exactly the same. Is equal to array world, row, and column. Okay, so that should handle the infection principle. Let's just quickly see if there's any questions on this. Okay. So how do we name our VPL file for our student details? You don't have to worry about that because you're going to submit in VPL, which is assigned to your actual student. When you download your submission like you did with the whole submission practice that you did, that whole zip file can just be uploaded onto Eve. So there's no need to worry about naming your file in a special way with your student details. Okay, so don't worry about that, but you could have renamed it if you really wanted to. Why do you delete type2 array when calling the void function in main? When you call a function, you don't specify the types. Okay, so you just specify the variables. So you can't go ahead and say this is a type2 array, whatever. Okay, you don't do that. Whenever you call a function, all you do is you actually provide the values of the parameters in the function, and this is the value. Array world is the actual value, which is of type type2 array. Okay, so hopefully that explains that. So remember, so when you call a function, you never ever specify the type. Do we need to copy the array? Yeah, at the end, we actually do make a copy of that. So, sir, in order to pass method 2, we must be able to write initialization, movement, update, and the end state of the game. Effectively, if you want to pass, you have to do the basic, or you have to be able to provide the basic game framework as demonstrated in the one video that Prof. Coulter already put on Eve a long time ago, which is effectively the whole, well, you basically have to make sure all of these things. Where is the, I didn't include, oh, there we go. So we look at the program design, the boilerplate code, coding style, functional abstraction, separate compilation, user interaction, command line argument, error handling, pseudocode. C9 and C10, these are the specific, well, and a little bit of the command line arguments. These are specific to each and every semester test, this stuff. The rest is fairly generic. Boilerplate code is generic. Coding style is generic. Functional abstraction is fairly generic, as long as you create functions that make sense and you actually use them. Separate compilation, this is basic stuff. There's no interpretation of the problem that allows you to not be able to do this stuff. User interaction, obviously the menu will have to be specific to the problem, but these are the basic things that you need to pass. So only the interpretation of how the movement will work, that falls under the algorithm implementation. The interpretation of how the game is initialized will fall under C9, which is where you will get those marks. So there's no excuse for actually not passing this, because it's the same little method over and over and over and over again. So how do you bring up the autofill? You press Control Space. Okay, Control Space. It's not the best autofill, but at least it's something. So if you, for instance, would know if somewhere in the file you used a specific variable and you press Control Space, it actually brings that up for you. Thank you for that. Yeah, Control Space. So the concept of having a temp array simply involves making the temp array carry the changes and then equate it to 100%, Mr. or Mrs. Lebaka. So can you please rephrase the update question? The update question is this section. The update basically says that count the number of, so firstly, if there is an susceptible character or a recovered character in that place, then they become infected by calculating a specific chance, which they call, in this case, a cumulative chance of getting infected. Okay, so we calculate a cumulative chance of becoming infected, and if that cumulative chance realize, then our character then suddenly changes from susceptible to recovered. Okay, so we basically calculate this cumulative chance to see whether we will become infected or not. So, sir, what are C++11 features and can we use that? I think we have discussed that on Discord, but there are a few things such as null pointers, auto prepending, and so forth. What do you need to do in Swift? Okay, that was the same thing there. Is C++11 features. I think Prof. Coulter did discuss it somewhere on the Discord, but again, just ask that. Since the test is on Friday, is there a prac due for Friday? Please check Eve. I'm not even going to answer that. Prac 9. Have you looked at Prac 9's deadline? Are we allowed to cray? I don't know what cray is. Do bonus marks make you get 100%? Well, obviously it will be capped to 100%, but effectively you can get more than 100%, but that actually helps you with your final mark eventually. But your final mark will never be more than 100%. So what is that structure on the mark sheet? The structure on the mark sheet explains exactly how the marks get affected. This is the same structure as we've had in the past pracs. So please have a look at the past pracs, but that structure describes exactly how marks get assigned. Surely you must have done some past test or not, but that structure is the mark sheet. Create classes. Are we allowed to create classes? Yes, you are allowed to create classes if you want to, but please make sure that you do proper allocation, deallocation, initialization, and you do use a dynamic two-dimensional array somewhere in your code. What is the bonus mark allocated to? Basically C++11 features. Okay. Okay, so we don't have a lot of time. I just still need to make sure that I actually test this. Okay, so we're still busy with update, and this just handled the first problem or the first bullet. So let's have a look at the second bullet now. An infected character has a fixed chance. Now, fixed chance basically means it doesn't cumulate. There's just one chance that exists, and that is the chance that it will recover. So let's have a look. An infected character has a fixed chance of recovering each turn. This chance is specified in the command line, obviously. We've had a look at that. So all we have to do here, let's see if this is an infected character. So array world, row column. If this one is val, I think infected, then we are going to see if the character is recovered. And it is a fixed chance. So this chance of getting recovered is a fixed chance. So all we do now is we again generate some random number between 1 and 100. Right? And then if int chance is less than or equal to this chance, because it's just a fixed chance, it's a very simple. Was it infected? No, recovered. Here we go. Then there's an opportunity to become recovered. Then they basically become recovered. But now, see if the character becomes immune, because that's also what is stated here. It says that When an infected character recovers, they have a fixed chance of becoming immune. So let's have a look at that. Okay, 5 more minutes. So let's see if, let's generate another random number. Obviously, we cannot, so we're just reusing our int chance again. And then if int chance is less than or equal to, not recovered, but if immune, then our character becomes immune. So in this case, our array temp is now value immune. If they don't become immune, they are value, it's just normal recovered. I'm going to remove that to make it a little bit better to read. Okay, and if there's no chance that they actually recover, then they basically stay whatever value they are. So else array temp is basically whatever value that was, which was infected. Okay, so that should handle the whole recovering section. So just save that. And let's have a look and see what happens. Okay, let's see. I think I can zoom in here. I'm not sure if it will show. I hope it shows zoomed in. I have no idea. Let's see. It shows. Okay, great. I'll zoom in like that. Let's zoom in. So let's go to the next round. Okay, there's a. There we go. That's a great error. I love this because this is the type of error that you guys are also getting. And then you ask me, well, what went wrong? I don't know. Let's explore this. Now I know exactly where my error is. And the error is in this count around. What is the problem with this specific section? So I'm trying to count around my character. Now remember this row and column. Let's have a look. So let's say I start at this location. So let's say there's an infected character right there. And now I want to count around it. And I want to go to row -1. Then I'm out of bounds. And I want to go to column -1. So you can't just go ahead and access a location that is not inside the world. So the first thing that we have to do is we say if is in world. I actually have this function, int rows, int columns, row and column. If it's inside the world, then I do this little if statement. Only then do I count and see if the section is inside the world. Let's see if I do. No, I'm not at risk anywhere else. I think this is the only place where I will basically get this error. Let's see, save. Let's run again. Zoom in. Hey. What the hell? Sorry about that. Okay, so far, oh, our recovered guys are actually going up. Our susceptible guys are coming down. The infected ones are going up. There's no immune. Infected is coming down again. Recovered. Ah, this is interesting. as what I like about this, as the infection people are coming close to those that's recovered, you'll see that those numbers should actually go up and down. And there's still some more. Okay, I'm going to stop here right now. Guys, our time is up. Thank you very much for your attendance again this evening. Please, guys, remember to use the Discord channel to ask questions. Anything to do with this lecture, with questions about open book, what you're allowed to do, not allowed to do, please have a look at that. We'll try and again send out an email specifically covering what we deem as open book, what is allowed in the email as well. What we see is in the open book or not. So please have a look at this code again. Tomorrow we will continue with this lecture and then have a look at the end game. Now you'll see that there's a few funny things in the end game, which will probably mean that we are going to have to do some changes in our code. Thank you very much, guys. Have an excellent day. Bye.